Today we're going to be talking about the very exciting topic of reciprocal trig ratios. Now this subject is very much related to SOHCAO trig, so if you're not quite sure what SOHCAO is, then I would definitely recommend checking out the Auducation video on that particular topic. But if you're good on that, then why don't you stay through and see what we have to say about CHOSHACAO today. We use our new friend CHOSHACAO anytime we're trying to find the cosecant, secant, or cotangent of an angle in a right triangle. Now using this is almost exactly the same as using SOHCAO. You follow the steps that we have here, right? First, you identify which sides are opposite and adjacent to your angle and which side in the right triangle is the hypotenuse. Then you use CHOSHACAO to identify which sides you need to produce the desired ratio, and then you just set up the fraction. It's pretty easy. So why don't we take a close look at CHOSHACAO real quick, and then we'll try an example problem where we have to find the cosecant, secant, and cotangent of an angle. First of all, just like SOHCAO, CHOSHACAO is actually three different statements. We have CHO, SHA, and CAO. Each of these relates to a ratio that we have down here below. First in blue, we have cosecant is equal to the hypotenuse over the opposite side. Secant is the hypotenuse over the adjacent side, and cotant is the adjacent side over the opposite side. Now, I don't want to linger too long in this particular detail here, but you'll notice that cosecant is the reciprocal of sine, right? And secant is the reciprocal of cosine, and cotant is the reciprocal of tangent. How do you know? Take each of your ratios and flip them over, and you'll have the ones for sine, cosine, and tangent respectively. In other words, if I flip over hypotenuse over opposite, I get opposite over hypotenuse. So what we've just done here is basically established a relationship between cosecant and sine. But let's save that one for another day. For now, why don't we go ahead and take a look at an example problem. Here we're asked to find the cosecant, secant, and cotangent of theta. We can see that the opposite side is 6, the adjacent side is 5, and the hypotenuse is the square root of 61. To find our ratios, we'll use our new friend CHOSHACAO and write down the appropriate fraction using the appropriate side lengths. And we're going to do that like so. The cosecant of our theta is going to equal the hypotenuse of the square root of 61 over the opposite side, which in this case is 6, and that's my cosecant. See, not so bad. Secant of theta is going to equal the hypotenuse, which is, again, the square root of 61, over the adjacent side, which this time is 5. And that is the story of secant. Finally, cotan of our theta is going to equal the adjacent side of 5 over the opposite side of 6. And those are three trig ratios. So once again, we'll sum things up here. First, you have to identify which sides are your opposite and adjacent to your theta, and then identify which one's your hypotenuse. It's the longest side or whatever is left over. Then use CHOSHACAO. Then set up the fractions using the appropriate side lengths. Isn't that easy? I think it is, and I know you can do it. Thanks for coming. See you next time.